How are you, my friends? This is lecture number 22 of the Calculus 1 lectures, Antiderivatives and Initial Value Problems. In the objectives of this lecture, we will define antiderivatives and antidifferentiation. We will use integral formulas. We will look at very simple differential equations, and there is an application about velocity and acceleration. Now, this is really an important slide because it relates the function f with the derivative and the antiderivative. So look here, please, on the right side. See, we have a function f here, small f. This is the function. If we use differentiation, the process of finding the derivative, so the derivative will be f prime of x. We have seen this in the previous lectures. Now we will do the opposite, the anti-differentiation process. And there we will find the antiderivative, which is capital F of x. So an antiderivative, this is the definition, an antiderivative of the function f is another function, capital F, such that capital F prime of the x is equal f of x, small f of x. So differentiation undoes the result of anti-differentiation and are opposite of each other. If we look at simple example here, given a function f of x 3x squared, find an antiderivative of the function f, which means find a function whose derivative is this f. So easily by little thinking, we can have capital F x cubed is an antiderivative of this f. Because try to find capital F here prime. It will be 3x squared. Bring the 3 down, subtract 1. Also, look here. Also, the following functions, this is function m, capital M, function capital L of x, function capital N of x, function h of x. All of these, x cubed plus 7, x cubed minus square root of 2, x cubed minus pi, x cubed plus 9.3, are also antiderivatives of this given function f. So you see the difference now? You can have the antiderivative in general, it will be capital F of x will be x cubed plus a c. See, c is a constant here. It can be any number. 2, 4, 1, 0, 3, 1.6, square root of 2, square root of 7, half. So c is any real number. So this is the antiderivative in general, x cubed plus c. Now, what do you mean by indefinite integral? The collection of all antiderivatives of the function f is called the indefinite integral of f with respect to x. So if we have this sign here, this is integration. So this is integral of f of x dx. It will be capital F of x plus c. If and only if you find the derivative of the capital F, it will be this small function f. So indefinite integral here, we can call it the most general antiderivative. Another example here, very simple example. Find the following indefinite integrals. Integral of 1 dx, integral of 2x dx, integral of x cubed dx, integral of cosine of x dx, integral of sine of 2x dx. 5 simple examples in example 2. This is so easy. Find a function here whose derivative will be 1. So it can be x plus c. You have to put here plus c to give the most general. Integral of 2x. Which function we can have on the right side whose derivative is the 2x. It will be x squared plus c. Now, after a few minutes, we will have a formula so that when you have a more difficult question, you can use the formula. Integral of x cubed, you can think here, it will be 1 over 4 times x to the power 4. Why? Because when you bring the 4 down, it will be cancelled with the 4 in the denominator here, and then you subtract 1, it will be x cubed. So this is the antiderivative or the indefinite integral. Integral of cosine of x dx, it will be sine of x because the derivative of the sine of x will be the cosine of x. Integral of sine 2x, it will be minus half cosine of 2x plus c. So one can verify, you can always make sure this is correct answer by differentiating the right side. Now this is the first integral formula, which is very, very important. The integral of x to the power n dx, you can write it as x to the power n plus 1, so we add 1 to n, divided by n plus 1, plus a constant c. You can use this formula if n is not equal to minus 1 only. If n is equals to minus 1, then we will see another formula later. Let's look at this done example. The integral of x to the power 5 dx. Just put x to the power 5 plus 1 divided by 5 plus 1 plus c. Simplify more. It will be x to the power 6 divided by 6. Or you can write it, you can leave it like this, or you can write it as 1 over 6 x to the power 6 plus c. Now this is the capital F. If you differentiate this one here in the yellow color, you will get this function inside the small f. Now this is a list of 4 integral formulas. The first one is the one we have seen now. And this is number 2, number 3, and number 4. So the integral of cosine kx, see there is a coefficient here, 2x, 3x, pi x, half x, whatever. It will be 1 over k sine of kx plus capital C. So that's a formula number 2. Formula number 3, the integral of sine kx dx, it will be minus 1 over k cosine kx plus capital C. Number 4, the integral of exponential e to the power kx dx, it will be 1 over k e to the power kx plus capital C. So these are the basic 4 integral formulas you can use anytime you like. Now these are simple properties. If you have a constant inside the integral, you can take it outside. We know that it's so simple. This is small c actually. This is small c. It will be here like 5 or minus half or pi or 10, whatever. If you have the integral of a sum, it will be the sum of the integrals. If you have the integral of the difference, it will be the difference of the integrals. That's the 3 simple properties. Let's look at example number 3. The integral of x cubed plus 3 square root of x minus 4 over x squared dx. So now all this inside the bracket, this is small f, f of x, the function. We have to find the antiderivative. So to integrate, we can use the properties here. See, this is a sum, this is a subtraction, and we have to use the first integral formula also 3 times, because this x 4 over x squared, we can make it x to the power minus 2. We can still apply the first integral formula. So this will be integral of x cubed dx, you see that? Plus 3, this is a small constant here, 3 outside, 3 integral of x power half, because this is square root of x, dx minus 4, another constant here, integral of x to the power minus 2 dx. Now this will be x power 4 over 4 plus 3. This you add 1, so x to the power 3 over 2 divided by 3 over 2. And here we have minus 4. You add 1 here, minus 2 plus 1. It will be minus 1 divided by minus 1 plus c. So this will be 1 over 4 x to the power 4, 3, and this is divided by 3 over 2, which is 2 over 3, so there will be 2 there. X to the power 3 over 2, you can write it as x square root of x, or you can leave it if you like. But I just put an idea here. If you want to do that, x to the power 3 over 2 will be x to the power 1 times x to the power half. Because when you add the power here, 1 plus the half, it will be 3 over 2. So you can leave the x times the square root of x. If you want to learn this idea, you can use it, or you can leave here x to the power 3 over 2, or you can leave it as x times square root of x. And there is a 2 here from the division. 3 divided by 3 over 2 will be 3 times 2 over 3. And this is minus 4, see, minus, and this minus becomes here plus 4. And this you can bring it down, it will be 4 over x plus capital C. One big constant here we can leave for the whole function. Another example with the sines and cosines and exponential. You can use the list of the formulas. So we apply the integral formulas 2, 3, and 4. This is a constant 2, it will be outside. This is a constant 5, it will be outside. And this is a constant 3, it will be outside. So we can use also the properties. See? So we have cosine of 3t dt. It will be, this is the constant 2, 1 over 3. So this is k. This is the coefficient of the t, which is 1 over 3, sine of 3t plus this 5. Integral of sine 4t will be minus 1 over 4 cosine of 4t plus 3 e to the power 7t. So this is k again. 1 over 7 e to the power 7t plus 1 capital C for the constant of integration. We call it constant of integration. So this will be the final answer. 2 over 3 sine of 3t minus 5 over 4 cosine of 4t plus 3 over 7 e to the power 7t plus capital C. Now, if you differentiate all this big guy here, you will get the function inside. Let's look at very simple differential equations. A differential equation, this is the definition. A differential equation, we call it DE, is an equation that involves differentials or derivatives. See, it's an equation. We have linear equation, we have quadratic equation, we have exponential equations, we have trigonometric equations. This is a differential equation. So you have inside the equation something with derivatives, like y prime is equal f of x. See, that's an equation. So we need the y here. So use anti-differentiation. So you get y will be the integral of f of x dx. Now these are very simple equations. Later in other courses, maybe you can see more difficult differential equations. Let's solve this differential equation. Y prime is equal to 3x squared. Now to solve the differential equation dy over dx, which is y prime, is equal to 3x squared, we just integrate. Y of x will be the integral of 3x squared dx. And we can use the first integral formula. So 3 is outside, then x cubed over 3. You can cancel the 3 plus capital C. So y now, the answer, the solution of the simple differential equation will be y equals x cubed plus capital C, which is a constant. Now, initial value problems. An initial value is a problem of solving differential equation. So we will have a differential equation here. Y prime is equal dy over dx is equal small f of x with initial condition. So we have a condition here, y of x sub 0 is equal y sub 0. So that's a condition given on y. So the reason for this condition is to find capital C, okay? So look at this example. Solve the initial value problem. Y prime is equal to 2x plus 3 with y of 1 is equal to 2. This is y, remember, not y prime. The condition on the y of 1. So if you replace 1 in the function y, the answer, it will be 2, so that you can find capital C. So this is y prime now, 2x plus 3. So what do? We just integrate. This is y prime 2x plus 3. So let's find the general solution of this differential equation. So y will be the integral of 2x plus 3, all of this dx. So the first one, it will be x squared plus 3x plus capital C. See, C is a real number. It can be any number there. But since we have a condition, initial value, y of 1, so I can put here y of 1. So I put, instead of x here, I put 1 squared plus 3 times 1 plus capital C is equal to 2. It's given here. All right? So C will be minus 2 because 1 plus 3 is 4. Take it on the other side, minus 4 plus this 2, C will be minus 2. So this is the particular solution, the special solution for this condition. Every time we have a different condition, we will have a different answer. So this answer here for this initial condition, so y of x will be x squared plus 3x minus 2. Now this is about velocity and acceleration. If we have a particle moving in rectilinear motion along a straight line, maybe on the x-axis, then the motion of the particle is described by the position function. That's the important point you have to know. Position function, which is x. X, we can write it as x of t. At time t, it is changing. So x is equal x of t. Now the velocity will be the derivative of the x. V of t will be dx over dt. So if you differentiate the position function, you will get the velocity. And remember, this is the opposite here in the conclusion. X of t, the position function, is the integration of the velocity v of t dt. So if you have the position function given, as we have seen before, then you can find the velocity here down. You differentiate the position function x of t. So it will be dx over dt. If you have the velocity, you need the position function, you integrate the velocity. Same thing for acceleration. A of t is acceleration. This is the derivative of the velocity, dv over dt. Or acceleration will be the second derivative of the position function, d squared of x divided by dt squared. And if you have the acceleration given, you can integrate to get velocity. Now let's look at example number 7. A particle starts from rest, that is the initial velocity is 0 at the x equals 10. This is the initial position, x equals 10, and moves along the x-axis with acceleration function a of t is equal to 12t. Find the position function. To find the position function, this is x of t, we have to go through the velocity actually. So the acceleration function is a of t is equal to 12t. So first, we solve the initial value problem, because the acceleration here, a of t, which is 12t given, this is the same as the derivative of the velocity. So this is like v prime is equal 12 of t, with v of 0 is equal to 0. This is the initial velocity, it was 0. So v of t will be the integration of 12t dt. So 12 is a constant. Integrate t, it will be half t squared plus capital C sub 1. So this is a constant. You can say k, or you can say only capital C. It's up to you. C of 1, because we have another constant in the same question. So 12 times half here will be 6t squared plus C1. Now let's use the condition here. V of 0 is equal to 0. So put here V of 0, it will be 6 times 0 squared. So C1 will be 0. So now we have the velocity function here, 6t squared only. Now we have another initial value problem, another one here, because we need the position function. The derivative of the position function is V, the velocity, and V already 6t squared. But x of 0 is 10. It was given. So we can integrate again to get the position function, x of t. We integrate 6t squared dt. So it will be 6. And to integrate t squared, you add 1. It will be 1 over 3 times t cubed plus capital C sub 2. So this is another constant. So it will be 6 times 1 over 3, 2t cubed plus c sub 2. Now you replace x of 0 is equal to 10. So I put here 0, 2 times 0 cubed plus c of 2 is equal to 10. So the constant now, the second constant in the position function is 10. Now look at the final answer. The position function is x of t, x of t, 2t cubed plus 10. Now we are finished. Now we can move. So please always check the playlist Calculus 1 solved questions. You will find many questions there and many videos to understand the lectures more and more. This is the end of lecture 22. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.